So we know that we can use a table when we're trying to find a rejected character from a rejected array in some string, where with a table, when we're looping over the characters here, we don't need to check each cases here, right? So we can put the rejected characters in the table and then use some value to indicate that it's actually a rejected character. Otherwise, we have set all the other indices to have the value of 0. And I guess 1 is used to indicate that it is rejected. And so when we are looping over the string, we can just use a table and then, put the character we are currently at as the index and then get the value to check if our current character in the string is an accepted or rejected character, or it's null character, and do something, right? Well, I guess I forgot to put break here, but and so in this case we are just using the values in the table to indicate different states. The actual number here doesn't actually matter, and that's fine in this case because, well, we just want to check for a rejected character. But we can actually use the table or put more useful values in the table when we actually need to. So let's say we have a substring needle. I put some thing there, and we can actually put more meaningful values in the table. We can put all the characters here in the table, and E, and for each character we are putting into the table, we can put as the value its position in the actual array. So I guess we can use a pointer here. NEP, and then so if we print this, it's just gonna put the position it is in the array, right? A is the first or the 0th character, B is the first, C is the second, D is the third, and so on. So let's say we have a string here and we want to scan the needle in the string here. We want to get A, B, C, D, E, F, the A here, right? So what we can do here is do a memcompare, and memcompare fails, and so we can actually skip the whole needle length to W, and since W is not in the needle, we can skip again A, B, C, D, E, F. That's what, 6? I don't know, around that here, and then we see that B is in the needle, and if we check the shift table, we can see that it will have a value of 1, right? Because it's the first character, right? And so what we can do here is shift 1, and then we can do a memcompare, and then we have found a string or a needle in the haystack. And so we have actually skipped a lot of memcompares. And so with the table we can do a lot of skips where we couldn't if we just checked for A and do a memcompare for every A. And so that is sort of how mem uses a table to skip a lot of memcompares. So it puts all the characters but the 0th character in the needle into the shift and puts the location of the thing, right? And it uses a hash here, so it uses 2 characters. Where is it? Hash 2. So it uses the current character and the character before it, and then it skips around the haystack and then checks the value of the current character, the hash of the current character in the shift table, and if the value is 0, it means that it's nowhere in the table, right? So the current character in the haystack is actually nowhere in the needle. And so it also checks if, checks for bounds, right? And so it skips the haystack again, and M1 is, I think, needle length -1, okay? And then, so it's going to skip around the haystack until it finds a hash of a character that exists in the needle, right? A character pair that is in the haystack that is also in the needle. And once it finds that, the TMP is no longer 0, right? The TMP holds the amount we need to shift to the left to do a mem compare, right? And so we shift back to do a mem compare, but before that we're going to check the TMP, which is the amount we have shifted to the left, to check if we have actually matched the last two characters in the needle. Otherwise, we continue the loop and then skip around until we have matched the last two characters in the needle, that is in the haystack. And if we have matched the last two characters, we are going to do a mem compare. But if it's a long needle, it's going to check only 8 bytes first, instead of checking the whole needle, and check if that matches. And if that matches, it's going to do a mem compare to check the whole needle length. Well, if it's a short needle, it's gonna just execute a mem compare for the whole needle. And if mem compare succeeds, well, we have found the needle in the haystack. Otherwise, we're going to skip around the haystack to find the last two characters in the needle in the haystack. And the offset here, I'm not actually too sure about, but let me know in the comments if you know about the offset here.